Ensemble models and bagging. So what are ensemble models? What is the idea? So we have uh, recapped what is decision trees, revised what is decision trees. Now if we know the limitation of a decision tree, it is prone to overfitting. It can overfit very easily. So as the number of splits increases, it uses greedy approach, and using this greedy approach, it has a lot of variance. Variance is high. So rules are very much over optimized for the training data. So in order to encounter this, we have another technique called as ensemble models. So combined results of multiple models is less wrong than a single model. That is a wisdom of crowd. It is generally related to the example of voting, where we have a voting system, where the majority always wins. Majority wins. This is for the classification task, right? And for the regression task, we take the mean value. We take the mean value of the leaf node. So let us see what is how a ensemble model of bagging is made. So the nature of Bayes learner. Bayes learner is a decision tree with max depth high. Let's say infinity, or whatever the data set highest number would be. Let's say we allow the Bayes learner to grow as much deep as possible, so that it is overfitting. It has a high variance and low bias. Low bias means we have a expert, you know, because it is having a low bias and the variance is high, but expert in a specific domain only. So we train n number of experts. Every expert is specializing in its own domain, and we take the aggregation of it. So bagging is simply just the two step. First step is the sampling, where we train the n estimators and trees on 60. Just this is a random number on 66% of the data, and the remaining 33% are unseen to the data. So my tree just is exposed to the 66% of the data, and it is then making a prediction. And we have hundreds of trees like this. So the final prediction would be the majority voting of this 100 trees. Therefore we get a the wisdom of crowd. We reach the wisdom of crowd if the majority of the trees are uh, predicting class 1, then it is a class 1. So why this works mathematically? Because here we have example also. Let's have a look at example first. So let's say we have some conditions. Let's say tree 1 learns a rule of temperature greater than 100, bp greater than 100, hr less than 100. Tree 2 learns temperature less than 101, bp less than 120, hr less than 110, and T3 also learns something, I don't care, right? So if we ask the prediction of this sample from all the trees, tree 1 says no, T2 says yes, and T3 says yes. Then we take the mode of all the trees, and it's a final prediction yes, right? As each week learner is making different mistakes. This is not the right word, this is a strong learner, because we are training experts. We have a team of strong learners, or we can say experts, that are making a prediction. Taking average will cancel out mistakes of individual strong learners. Average prediction is 1 to n prediction of I, and let's mathematically it is yi is just y plus some EI. EI is some random error that each base learner is making. So if we do the summation, we get 1 of n as common and summation of yi and then summation of error. This error fades out as we take the aggregation. As per the theorem, law of large number. Rules are overfitting training data. General rules, yes. If we take a single training data, rules will be overfitting to just training data. This would be an hypothesis. We don't know whether this hypothesis would be true for the other data set also. So what we do the sampling, and generally the sampling is done with the replacement is nothing but we allow duplicates also. Duplicate rows are allowed, and we test and we build hundreds of this hypothesis, and based on each and every hypothesis we make a prediction. So if my 60 of if the prediction of 100 of its hypothesis will result in some ratio, like let's say 60-40 or 50-40, 50-50 or anything. Generally 50-50 doesn't occur. Let's say if there is some majority 49-51, so we'll go with the 51 because this is an hypothesis, single tree, but when we take the majority, and the majority is always right, and that would result in low variance. Low variance means it would be a general rule, not an hypothesis, because we have estimated from n trees, not a single tree. Yeah, when hypothesis hold true for after experimentation on different data, it can become true. So here the key is every tree should be making different mistakes, as individual mistake would cancel out, as individual mistakes would be cancelled out by aggregation step. But if the trees are making the same kind of mistake, the mistake would get summed up and the error would still remain, right? Therefore each tree should be different from another tree. What are the limitations of it? Without sampling, backing model fails, as every model will learn the same thing. So the rules would be same, hypothesis would be same, and we'll end up with the hypothesis, not a rule. End up the hypothesis, not a rule, as we are not doing the sampling, right? So variance is change of dataset to change of predictions. Change of prediction is too much. Change of dataset to change of predictions. This is a wrong sentence. Variance is how much my predictions vary when samples change or the entire data set changes. If my predictions vary too much, then my variance is high. We have a formula. We don't know where this formula belongs to, but this formula is for my final model, I'm assuming. variance of h is p of sigma square 1 minus p by b. Correlation between trees. So if my trees are correlated, then what happens? 1 minus p, this would result in 0 and we are left with just this. So the variance of the trees would be the variance of my final model. But if my trees are less correlated, we'll have the entire term, so my variance would be much less. What is the formula mean? What is this? So the entire point of the formula I'm assuming is correlation between trees should be less. And this is the thing. 1 minus b by b. As b tends to infinity, this terms become 0. Let's say this is 0 only. If this is 0 and this is multiplication, everything's become 0. What nonsense. Variance formula for bagging model. The individual variance of a single fully grown decision tree is derived by the correlation between trees, how similar they are to each other, and the total number of trees in ensemble. The key insight is, if you add more trees, the second term shrinks to 0. The variance lower, the total variance cannot go lower than p into sigma square. Okay. Bagging trees on the same feature set keeping correlation relatively high and the forest crops are split. No, I don't need but I need an intuition. To interpret this formula. It's a group of financial advisors. This is the shared risk and this is the individual risk. Okay, the second term, the power of crowds. Unique random mistakes individual makes because they were trained on different subsets of data. If you ask 100 in a minute, I don't know. B tends to infinity, this entire tends to 0. You can completely end tree noise by building a larger forest. Okay, so if you build this in the shared risk is just the correlation between trees. Right. As let's say correlation between trees is 0.1 and we do this, so overall variance goes down. But if this is higher, the overall variance of the model would be higher. Therefore, the correlation controls the variance of the final model. As this can go to 0, we can add more number of trees. The entire thing depends upon the correlation. Okay, thank you.